Okay, so to finish off lesson 2, I'm going to do another quick example of kind of the similar type of work with the triangles and the different types of tangents and all the good stuff there. So we got in the diagram shown, we got PQ. So P and Q is tangent to the circle at point Q. So we have tangency at this point right there. QR is diameter of the circle, and line segment PQ is 9, PR is 44, and our triangle QCS is an equilateral. What's the length of the diameter QR? Well, this kind of follows the same sort of pattern as I did in the last question. We have a diameter. We have 90 degrees here, since, again, this is a point of tangency connected to a radius, which is connected to the center, so this is going to be 90 degrees. We know this is 9 and 41, so we're going to go ahead and use Pythagorean theory to solve for it. C squared equals A squared plus B squared. We know our C squared is the hypotenuse, which is always across from the 90 degrees. So 41 squared, and I'm going to go ahead and say minus 9 squared equals B squared. I'm going to pop this into my calculator, and I'm going to get 41 squared. I'm going to take away 9 squared from it right off the bat to get that this is 1600 equals B squared, and that should mean that B is going to be equal to 40. You can just verify that by taking the square root of 1600, and you're going to get 40. So from A, that we're going to have that length of diameter QR equals 40, and it looks like we're using millimeters. And again, that's just from using Pythagorean theory. What is the length of chord QS? Well, QS is the exact same as a radius measurement. It is not the radius, but it's the same length as a radius. And we know, since the diameter is 40 meters, we know that the radius is 20 millimeters. Sorry, I'm not using meters, just millimeters. So we know it's just going to be half of our diameter. And then C, what's the length of the chord RS? Well, we should know from last time and last video that this just happens to be a 90-degree angle here, since we have subtended arc RQ, subtends an arc that is 180 degrees as a central angle. So we know this is 90 degrees. And if we were to kind of rewrite this triangle here with our radius measurement of 20, our diameter measurement of 40, we can solve this one using the same types of Pythagorean theory as we did before. So we're going to type in our 40 squared minus 20 squared, and that's going to be equal to our B squared. So we can do that as 40 squared in our calculator, and I'm going to minus 20 squared right off of it, which means that we're going to have 1200 equals B squared. Let's take the square root of that to figure out what B is. And I got 34.64 millimeters equals B. And if we want our nearest millimeter, then we can say RS is going to equal 35 millimeters. Kind of a very short version of our last question. Lots involved in this one, but if you want a deeper discussion of like what everything, all the connected pieces are, you should watch the video just before this, where we do a very similar example to it. And this one I just kind of went for the answers and did the justifications as we went.